Hi guys, and welcome to this second tutorial looking at athlete monitoring data. In this tutorial, we're going to move away from the estimated mean of a group and move towards looking at the covariate, looking at including a covariate within the model so that we can get a straight line through the whole of the space of the covariate rather than categorizing it into groups. Now, to start with this tutorial, we're going to require Viz1 and Viz2, and then we're also going to need to have the script open in SAS. So if you remember from last time, what we had was this situation where we'd grouped all of the data into either 1, which was a low sleep, 2, which was a moderate sleep, and 3, which was high sleep. And we attempted to find out what the differences were between sleep groups and what well-being score we could expect between sleep groups for different athletes. And that gave us some indication that there was potentially a linear trend between increasing amounts of sleep, increasing wellness score the next day. However, you do lose a lot of the information by grouping into these -1 and +1 z-scores. And this is the mean-centered sleep plotted against the same wellness score. And you can see how this trend is much more obvious. So here we have, if they have 2 hours less sleep than average, here is 2 hours more sleep than average, and we go all the way up to 8 hours plus and 6 hours minus. And you can see there is actually a positive trend here that's much easier to see when we look at the mean-centered variable. So what we're going to do in this model is we are going to go straight through to SAS and just plot this model as it is at the moment to see how it looks. So we're in the mon script in SAS that we put in the athlete monitoring folder a couple of videos ago. And we're going to go down to the model, which starts on line 48. And the only difference here really is the inclusion of the MC sleep underscore SAS variable rather than the Z group sleep variable. When we include the MC sleep SAS variable, we don't want to include it in the class statement because it's not a categorical variable. It's simply a covariate. So we're now going to look and try and get a linear trend for every increasing hour of sleep, because this variable is in hours. So for every hour of sleep increase, what influence does that have on the wellness? And because it is centered around the mean, it will be every hour increase from the mean or decreased from the mean sleep. And as you can see, we've estimated the 1 hour sleep increase here. All we're doing is taking one portion of the MC sleep SAS. And then for the intercept, we're going to get a full view of the linear effect by looking at 6 hours minus and 8 hours plus, as I said before. And for that, what we want is we want to get the intercept, so one portion of the intercept and -6 portions of MC sleep to go 6 hours back from the mean. And we want one portion of the int and 8 portions of MC sleep to go 8 hours beyond the mean. And then we've done the same thing for these estimate statements for the individual athletes. Again, just making the adjustment for the specific subject or participant that we're looking at. So making the intercept adjustment for athlete 9 here, 11 here, 12, 13. So let's see how the model looks. And it will take a little bit longer to run this time because of all the intercepts that it needs to calculate. First thing we'll do when it's run is we'll check the log to make sure there's no errors. As we look in the log, we can see that It's no errors of it. There's no errors, there's no warnings. We can see that the time of the model in real time, it actually took 8 seconds to run, which is longer than the others have run so far. And then we can go straight into the results section. And in the results section, we see we only have name ID as our class now. And we still only have the between and within participant variances in the covariance parameters. Where things differ is we now have a solution for the fixed effects for the MC sleep SAS. And this shows that for every hour increase in sleep, when we move down to the estimate, we can expect about a 3% increase in wellness. And that's highly significant, so stupid word to use, but that is definitely significant according to the type 3 test of effects. You can see here we've got the solution for random effects like we've had in the past, which shows how the participants differ according to the main intercept. And then here we have the expected daily wellness scores for the intercept when they have 6 hours less sleep and 8 hours more sleep. We're going to use these in a graph in a second. And again, you can see the residuals look okay. Again, we have this little bit of high element of skew on the right-hand side of the distribution curve, and again at the top of the QQ plot. So let's go back into the visualization and have a look now at what the intercept looks like. And now you can see that the intercept is diagonal, and it's diagonal because we're looking at for every unit change, we know what this slope is, and that's why it's called a slope. When we have the categories, we can only have a flat intercept if there's no covariate, and then we make adjustments from that flat intercept. Now we could have categories that make adjustments from this intercept if we wanted to, which has this slope. But for now, we're going to keep it simple, and we're just going to look at the intercept as it is. And we'll compare that to all of our other athletes. So let's start with athlete 9. And you can see that for athlete 9, probably what's going to happen is when we put athlete 9's random intercept in, we're going to find that it comes a little bit down here because there's a little bit of a grouping of data points here, and it'll disregard these ones up here, unfortunately. So we're going to find it's probably going to be something around here when we put it in, when actually we'd quite like it to be more of a steeper slope. So let's see that. And there you go, it is a little bit lower, but as you can see, it follows the same gradient as the main intercept rather than creating a slope for itself. And that's because of the model we've specified. We can only change where the intercept is. We can't actually change with this model where the gradient can't actually be changed. Let's have a look at athlete 11 now. Athlete 11 is a little bit of an unknown here, I'd say, for me. Possibly slightly down, but there doesn't look to be a whole lot going on there. And you can see that actually they would almost be better off having a reverse slope in this situation. So almost like as sleep reduces, wellness increases, which is very strange. Let's see how that looks. And yep, that is slightly lower, but you can see how it completely disregards these points up here, and definitely probably it should at least be flat, I would say, if not slightly more on a negative rather than positive slope. Athlete 12 now. Athlete 12's all above the mean at this point, so I'd expect the mean to just move up. Again, what we'd probably expect if we could change the slope would be it to be more flat, but as it is, I just expect it to move slightly up slightly up towards the middle of where the random intercept is and the top of the graph. And that's pretty much what it's done. It's gone pretty much in the middle. But again, it would be better if we could have this side of the line a little bit flatter. And finally, athlete 13. And athlete 13 is the opposite of athlete 12. You'd probably expect it to be a little bit lower for this one because all of the values are below the intercept pretty much. And again, we can see that. So this is just an introduction to what a covariate could do. But one thing that I've been very clear to point out is that these slopes that we've got here probably aren't suitable for the athletes that are using them. Could probably do with allowing these slopes to differ and using what's called a random slopes model. And in the next video, we'll move on to the random slopes model so that you can understand how that works and what that allows you to do.